In this video, I'm going to show you how to use the tree diagram to illustrate the possible outcomes for a coin toss. At the top of the tree diagram, there are branches representing the possible outcomes for the first observation in the experiment. Each of these outcomes results in more branches representing the possible outcomes for the next observation in the experiment, and so on. Since we have two coins, we'll be showing two levels of branches. So we'll start with the first coin. Since the coin has two sides, one result is heads, the other is tails. I'll use H for heads and T for tails. There are the two possible outcomes for the first coin. Now we'll look at the second coin. Tossing the second coin also could result in either landing on heads or tails. But if we look at the other branching, if the first coin had landed on tails and we tossed the second coin, that second coin could also land on heads or tails. So we have two layers of branches because we have two coins that we're tossing. Now we're going to follow the branches to see what all of the possible outcomes are. So we have heads, heads for one outcome. Then we could go heads, tails. Next, the first coin could have landed on tails and the second coin heads. Finally, the first coin could have been a tail and the second coin could have been tail. So what we've ended up with at the end of these branches are the sample points for the experiment. So part B is asking us to list those sample points. So we have heads, 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 tails, tails, heads, and tails, tail. It is important to note here that even if the coins are identical in appearance, they are in fact two distinct coins. Therefore, the sample points must also account for this distinction. And that's why heads, tails is listed as a different outcome than tails, heads. So it looks like they're both heads and tails, but the order does matter here. So next we'll assign probabilities to the sample points. So that means, what is the probability of both coins landing on heads? So if we go back to our sample points, we see that head, head appears only one time out of 4 total outcomes. So 1 out of 4 is the probability for heads, heads. If you convert that to a decimal, then you'd have 0.25. The next probability is the probability of heads, tails. Going back to the sample points, only one of our sample points is heads, tails. So that would be 1 out of 4, which is also 0.25. The next probability deals with tails, heads. Going back to the sample points, we can see that tails, heads only appears one time out of 4. So again, 1/4 or 0.25. Finally, the probability of both coins landing on tail. That is our last sample point, and it is the only one out of the 4 tails, tails. So again, 1/4. So you can see that each one of these probabilities is exactly 0.25. So if we find the probability of the event A is defined as 2 heads are observed. Well, we only have one event that has 2 heads. So that would be 1/4 or 0.25. For part E, we're looking for the probability of the event B, which is defined as 2 tails are observed. So we look at event B, that's our 2 tails, that's 1 out of 4 or 0.25. And last, find the probability of event C, which is at least 1 head is observed. So the key here is at least. So it could be 1 head, it could be more than 1 head. So now we're looking at the option heads, 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 tails, tails, heads. So 3 of the 4 events. So our probability of event C would be 3 out of 4, which is 0.75. And this is how we can use the tree diagram to help us see what the possible outcomes are for the coin toss.